Okay, so today we're going to start our Chapter 8 notes, and our first section in Chapter 8 is all about the Pythagorean theorem. So if we know the lengths of any two sides of a right triangle, we can find the length of the third side by using the Pythagorean theorem. You might have heard of this before. If you haven't, that's okay. It's super simple. So our Pythagorean theorem says if we have ABC is a right triangle, then A squared plus B squared equals C squared. And our A and B are both the legs of the triangle, and our C is going to be our hypotenuse of our triangle. Okay? And a Pythagorean triple is a set of three non-zero whole numbers, A, B, and C. Oops. Whole numbers, A, B, and C, that satisfy our Pythagorean theorem. Okay, so if we multiply each number in the Pythagorean theorem by the same whole number, the three numbers that result also form a Pythagorean triple. So if we have our numbers 3, 4, and 5, we know that 5 is going to be our hypotenuse because it's the largest number, which means that our 5 is automatically going to be our C. So we know that 3 and 4 are going to be our A and B. So what we're going to do is we're going to have 3 squared plus 4 squared equals 5 squared. Okay, so when we do 3 squared, that's just 3 times 3, which gives us 9. And when we do 4 squared, that's 4 times 4, which is 16, equals 5 squared, which is 25. So 9 plus 16 is 25, and 25 equals 25. So this is a Pythagorean triple. Okay. So if we moved on to the first problem, we know both of our legs, and we just want to know what our hypotenuse is. So our legs are going to be our A and our B. So we're going to have 20 squared plus 21 squared equals C squared. Okay. So when we do 20 squared, that's 20 times 20, which gives us 400. And when we do 21 squared, that's going to give us 441. That's still going to equal C squared. So when we add our like terms on our first side together, that gives us 841 equals C squared. Remember, to get rid of this square right here, we are going to square root both sides of the equation. When we take the square root of 841, it's going to give us 29. So C is going to equal 29. And because C equals 29 and our A and our B are both whole numbers as well, we have a Pythagorean triple of 20, 21, and 29 is a Pythagorean triple because they're all whole numbers. Okay, so if you want to take the time to do this got it problem by yourself, by all means go ahead and do it. Just pause the video and work on it. Okay, so it tells us that we have the legs of our right triangle. So if we draw this out just like our last one, it says our legs. So if this is our right triangle right here, we can say that this is 10 and this is 24, and we want to know this, which is going to be C. So we're going to have that 24 squared plus 10 squared equals our C squared again. Okay, so if we do 24 squared, that's going to give us 576 plus 10 squared is going to give us 100 equals C squared. So when we add our like terms together, that gives us 676 equals C squared. To get rid of this square, we are going to take the square root of both sides, which gives us C equals 26. Because C is a whole number, we can say that 10, 24, 26 is a Pythagorean triple. Okay, we go ahead on to the next one. Now we're going to look at finding the legs of the triangle. So on the last page we found the hypotenuse, now we're going to find the leg. Okay, so that just means that we're going to have x squared plus 8 squared equals 20 squared. Okay, so now that leaves us with x squared plus 8 squared is going to be 64 equals 20 squared, which we've already found is 400. When we do that, that gives us, or the next step, we are going to subtract 64 from both sides, which gives us x squared equals 336. So if we take the square root of 336, it's going to give us a messy decimal. What we want to do is figure out how to make it the simplest radical form. Okay, so what we're going to do is we're going to do our factor tree. So if we have 336, we can divide that by 2. If we divide 336 divided by 2, that gives us 168. If we divide that by 2 again, that gives us 84. Divided by 2 again, that gives us 42. Divided by 2 again, that gives us 21. And that leaves us with 3 and 7 at the end. So since we have a pair of 2's right here, a pair of 2's right here, we are going to have 2 times 2 on the outside, and our 3 times 7 is going to be on the inside. So that's going to leave us with x equals 4 square roots of 3 times 7, which is 21. Okay, so that's going to be our final answer there. Move on to the next one that we have. So if you feel comfortable doing the got it problem by yourself, go for it. If you don't, you can follow along still. Okay, so if we have our right triangle, we know that the hypotenuse is going to be 12. We know that one of our legs is going to be 6. So our other leg is just going to be x. So we're going to have x squared plus 6 squared equals 12 squared. So that leaves us with x squared plus 6 squared is going to be 36 equals 12 squared, which is 144. So when we subtract 36 from both sides, that gives us x squared equals 108. So we are going to take the square root of both of those to get our simplest radical form. We're going to divide that by 2, which leaves us with 54. Divided by 2 again, which leaves us with 27. We can't divide that by 2, but we can divide it by 3, which gives us 9 and 3 and 3. So we've got a pair of 2's and a pair of 3's. So we're going to do 2 times 3 on the outside, and we're left with this 3 over here on the inside, which gives us x equals 6 square roots of 3. Okay. On our next page, we are just finding our missing length. So it tells us that one of our legs is going to be 26 inches. It doesn't tell us what our other leg is going to be, and it tells us that our hypotenuse is going to be 36. So all we're going to do is we're going to take, if we just call this one x, we're going to take x squared plus 26 squared equals 36 squared. Okay, so that leaves us with x squared plus 676 equals 1,296. So we need to subtract 676 from both sides. That leaves us with x squared equals 620. So we're going to take the square root of both of those. So if we divide these out, divided it out into 10 and 62. So that leaves us with 2 and 5 and 2 and 31. So we have a pair of 2's, which means we're going to have a 2 on the outside. So we're going to have x equals 2 square roots, and then we're going to have 5 times 31, which gives us 155. And that's going to be in inches. Okay. So we have a computer monitor. So normal computer monitors are just rectangles. And it says the length of its the size of the computer monitor is the length of its diagonal. Okay, so that just means from one corner to the opposite corner. So if we buy a 19-inch monitor, that means that this is going to be 19 inches right here. And it has a height of 11 inches. We want to know what the width is, so that's going to be our x. Okay, so we will have x squared plus 11 squared equals 19 squared. It's going to leave us with x squared plus 121 equals 361. That gives us x squared equals 240. So we're going to take the square root of both of those. It tells us to take it to the nearest inch, 1/10 of an inch. So if we just put this square root of 240 in our calculator, that gives us about 15.5 inches. Okay. Moving on up. Okay, so now we want to determine whether a triangle is a right triangle. If it's a right triangle. And how we do that is we use the converse of the Pythagorean theorem. So remember from chapter 2, converse means that we're just flipping our if and our then. So that means that if we have a squared plus b squared equals c squared, then our triangle ABC is a right triangle. Okay, so if we move down here, if we have the side lengths of 85, 84, and 13, we want to know if it's a right triangle or not. So our 85 is going to be our C because it is the longest. So we're going to have 13 squared plus 84 squared equals 85 squared. So 13 squared is 169 plus 7,056, and that should equal 7,225. If we add 169 to 7,500 or 7,056, that's going to give us 7,225, which equals, so since it equals, that means that we have a right triangle. Okay, so go ahead and work on the got it problem and go on to the next video to find the answer.